In this video, we'll be looking at the different neurons and their involvement with cerebellar ataxia. This is Steve, and he suffers acquired cerebellar ataxia due to a tumor he had a few years ago. Because of this, he suffers gait instability and dysarthria. Further signs of ataxia include sensory loss, muscle weakness, scoliosis, foot deformities, and absence of tendon reflexes. Cerebellar ataxia is defined as a lack of coordination of voluntary movement. Acquired cerebellar ataxia, such as Steve's, is caused by damage to the cerebellum or its pathways by means such as a tumor or a stroke. While ataxia doesn't sound fatal, it's a serious issue because it reduces life expectancy to on average 38 years old. For Steve, this means his life expectancy is less than half that of the average Australian male who lives until 82. To understand ataxia, one must first know about neurons. These are nerve cells which generate and conduct nerve impulses. They can respond to stimuli and transmit electrical impulses throughout the body. There are three functional classifications of neurons: sensory neurons, interneurons, and motor neurons. Sensory neurons, or afferent neurons, transmit impulses from sensory receptors to the central nervous system. Thus they alert the brain to stimuli. For example, when we see, sensory neurons take impulses from the receptors of the eye to the central nervous system. Interneurons exist between motor and sensory neurons, as can be seen to the left. They are responsible for carrying signals through the central nervous system pathways where integration occurs.
Motor neurons carry impulses away from the central nervous system to effector organs. The act of flexing a muscle, for example, involves motor neurons carrying impulses from the brain to the muscles involved in the action. The cerebellum is located dorsal to the pons and the medulla, in the posterior section of the brain. It tunes and controls movement. It governs muscle coordination by 4 steps. Firstly, motor areas of the brain's cerebral cortex inform the cerebellum that they wish to initiate voluntary muscle contraction. Simultaneously, the cerebellum receives information from proprioceptors throughout the body. This allows it to evaluate body position and momentum, i.e., where the body is and where it is going. Within the cerebellum, the cerebellar cortex calculates how best to coordinate all the components of movement. It develops a blueprint and so can be thought of as an architect of sorts. The cerebellum sends this blueprint to the cerebral motor cortex via the superior penduncles. Cerebellar fibers also send information to brainstem nuclei, which influence motor neurons to instigate action of effectors, and thus the body moves. In acquired cerebellar ataxia, damage to the cerebellum comprises one or many of the 4 stages above, and the blueprint, because of this, is not properly produced and/or communicated. Thus, while motor neurons are not themselves damaged, errors in communication between the cerebellar fibers and the brainstem nuclei mean that motor neurons do not carry impulses in a way which provides the intended action. This is why people with cerebellar ataxia quite literally cannot coordinate their movements normally. This is why Steve, for example, suffers dysarthria and unstable gait. Thank you for watching. We hope that this video has given you a greater understanding of the power of neurons and has consolidated your knowledge of the intimate and causal relationship between the nervous system and human physicality. Here is our list of references.